Okay, here they're asking us to find all the critical points for the function, and that is going to be where the derivative is 0 or where the derivative is undefined. So I'm going to go ahead and take a look at number 51 first. We got y equals x squared minus 32 root x. That means our derivative here is 2x minus 16 over square root of x. And our derivative is undefined at x equals 0. But if x is not going to be 0, then we can go ahead and multiply both sides by root x, and that's going to give us (2x root x minus 16). So let's go ahead, add 16 to each side. And that's going to be 16 equals 2. And I'm just going to write that as x to the 3/2. Now we divide each side by 2. And we get 8 is equal to x to the 3/2. And if we raise each side to the 2/3 power, we get x equals 4. Now, it may look like our critical points are going to be 0 and 4, but there's one thing that we need to make sure of before we commit to that. And that's that our points are in the domain of the function. So 4 is in the domain of our original function, and 0 is in the domain of the functions, the endpoint of the domain, but it is in there. So we do have critical values at x equals 4 and x equals 0. Next, we're going to take a look at y equals natural log x plus 1 minus inverse tangent of x. So again, we're going to want to take the derivative. Derivative of log of x plus 1 is 1 over x plus 1 minus the derivative of inverse tangent is 1 over 1 plus x squared. Sorry, I had to think about that for a moment. And in order to go ahead and see, we've got to see two things. We've got to see where is our inverse function undefined, and that's going to be at where x plus 1 equals 0. It's undefined at -1. So that is a potential critical point. We'd also have to, we could take a look at 1 plus x squared equal to 0, but since x squared is always positive, that will never equal 0. So now we've got to see where the derivative is equal to 0. And really the easiest way to do that without running into trouble here is to just go ahead and put these things over a common denominator. So we have 1 plus x squared on top, and then it's going to be a minus x minus 1, because this minus here is going to have to go distribute to both. And this is all over x plus 1, 1 plus x squared. And this is going to be 0 where the numerator is equal to 0. So that's going to be x squared minus x, which we could write as x times x minus 1, which gives us at x equals 0 and x equals 1. So for critical values here, we have potentially 3 critical values. But when we go back to the domain of the original function, the domain of inverse tangent, that is all real numbers, so that's not a problem. But the domain of natural log of x plus 1 is x is greater than -1. So because of that, we don't get to keep -1 as a critical value, and our critical values here are x equals 0 and x equals 1. So process-wise, find the derivative, see where the derivative is undefined, see where the derivative is equal to 0, and then the points that you get to keep are the points that are in the domain of the original function.